Okay, let's unpack this. Welcome to this deep dive, which we've put together specifically for you, looking at the source material you sent over. Today, we're tackling something really persistent, I think. How to understand and maybe more importantly, reduce operator error, especially in, well, demanding fields like mining.
And it really is a challenge that sticks around, doesn't it? These sources really highlight that. Even with all the amazing tech we have now, you know, governors, proximity sensors, fancy telematics, human judgment error, it's still behind a pretty big chunk of incidents.
Right. It feels like we keep layering on tech to sort of catch the problems, but that human element, those, split-second calls an operator makes, they're still right at the heart of it. So our mission, I guess, for this deep dive is to explore this specific approach your sources outline. It sounds like quite a proactive strategy, and it seems to pivot the focus onto an operator's psychomotor ability using data and some really specific training.
Exactly. We're going to be digging into these articles and research notes you shared. They detail this particular method and how it's been used, particularly, like you said, in coal mining, as they try to, well, get ahead of these errors.
Okay, so jumping right in, one of the things that really jumped out at me, mentioned early on, was the stat from a 2018 study, South African underground coal mine. And the finding was, well, a really significant percentage of accidents, 45%, actually they pinned on what they called judgment error.
Yeah, that 45%. It's hard to just brush past that. And the sources, they define that judgment error
Yeah.
pretty clearly in this context. It's basically an operator failing to properly see, then recognize, and then critically react to hazards, especially during things like risk assessments or just, while actually operating the heavy machines. They really frame this around the idea of psychomotor or maybe visual motor ability.
Okay, and this kind of contrasts with the existing tech, doesn't it? What the source calls the mechanistic approach. Things like, speed governors or the telematics tracking every move, which are vital, obviously, for monitoring. But the drawback they point out is that they're mostly reactive. They give you the data or the alert often after something's already happened.
Right. Which means you're often tackling the result of the error,
Yeah.
not the actual root cause, the failure to see or react properly in the first place. And this is where the sources bring in this really crucial human factor that definitely caught my eye. They state that psychomotor ability, that link between what your eyes see, your brain processes, and how your body reacts, it naturally starts to decline. And they actually pinpoint this decline starting, well, surprisingly early for a lot of people, specifically after their early 30s.
Hang on, declining after your early 30s.
It can.
That really does sound young. Did the sources explain why? Like, why that age? Or what specific skills are affected? Is it reaction time, peripheral vision?
They didn't dive super deep into the, let's say, neurobiology of why in these specific papers. No. But the implication is that sort of core visual processing speed, your reaction coordination, handling multiple things at once, those can start showing subtle but measurable changes around that. But what they really stress is the value of knowing an operator's skill level, whatever their age, and tracking how it shifts over time. They actually used telematics data from underground vehicles and compared it against these annual psychomotor assessment scores generated by a system they called Driver Bureau.
Ah, okay. So connecting the human skill score directly to how the machine is actually being handled, that feels like where you'd get some real insights. What did they find when they mapped those two together?
Well, one really interesting thing was that operators who scored lower on these sort of eye-brain motor tests, they weren't automatically the ones having accidents. That wasn't a direct line. The key insight, it seems, is that raw skill isn't the only thing. They found those with lower scores could still operate safely, but often only if they were really self-aware about it, conscious of their limitations and maybe compensated by being extra cautious.
So that awareness is a big factor. And the
Correct.
sources suggest you're not just stuck with those scores, right? You can actually influence them, improve the skills. They talk about proactively moving operators. I think they used quadrants from a zone linked with poor scores and potentially worse safety outcomes towards a better one. And sometimes quite quickly, just using targeted feedback.
Yes, exactly. That's basically the foundation for their visual performance journey. It's structured in two levels. Level one is a baseline psychomotor assessment, usually done annually on a computer or a tablet, something like that. And that's followed up with personalized feedback. The sources mentioned this feedback can sometimes use AI, actually, to help really pinpoint the specific areas where an operator might need to, focus their attention.
Okay, so level one, assess where you are, get clear feedback on your specific psychomotor pluses and minuses. What's level two then?
Level two is where the targeted intervention happens. They use a training system called iGym. You can think of them as kind of digital drills,
Mm.
basically designed to improve that eye-brain-hand coordination and your processing speed. The sources suggest that improving these specific visual and motor skills, it doesn't require huge amounts of time. They mentioned something like 9-10-minute sessions spread across the year.
9-10-minute sessions a year. That really doesn't sound like a massive time commitment, operationally speaking, especially if it actually works. Which leads to the big question. Did the studies, the ones using the telematics data, did they actually show improvements tied to this program?
According to the sources, yes, they did. They measured positive impacts using that telematics data. They looked at those typical metrics, the ones directly linked to operator behavior and machine stress. Things like reducing harsh operating events, sudden braking, sharp turns, that kind of stuff. And these events often link directly to better fuel consumption, less wear and tear on the machines, and, yeah, fewer accidents.
And the bottom line there is better machine availability, lower operating costs, all critical in mining, right? So the claim is this proactive approach, this visual performance journey, by really zeroing in on the operator's underlying skills, it can measurably improve those key operational and safety numbers.
That's the core argument, yeah. By shifting away from, say, just investigating incidents after they happen, or only relying on rigid mechanical limits, and instead actively supporting the human operator's dynamic skill set, understanding their level, managing that natural decline, providing targeted training. The sources suggest you can get real, tangible improvements, both in safety and in efficiency.
What this really seems to boil down to, then, is a pretty fundamental shift. A shift in how we think about operator performance and managing safety. It's not just about ticking compliance boxes or engineering the machine itself, but about actively developing and maybe supporting the person who's actually operating it.
It really is, yeah. And it brings up an important question about how we view skill itself, doesn't it? Not just as some static thing you check during hiring, but as something dynamic, something that needs ongoing attention and support throughout an operator's whole career, especially when you factor in things like that age-related skill decline they mentioned after the early 30s.
And the sources are really specific about how this tool should be used, aren't they? They make a point of saying this program is not designed for or intended for employment screening.
That's a crucial distinction they make, absolutely.
Why do you think they're so specific about that? What are they trying to head off by saying it's strictly for managing existing employee skills?
Well, it wasn't spelled out explicitly in the material you provided, but you could probably infer. They likely want to stress that it's a developmental tool, a support mechanism, not some kind of gatekeeping barrier to entry.
Right.
It's about continuous improvement, managing those natural changes over time for the people already doing the job, rather than using it as an initial filter when hiring. That could raise a whole different set of, potential issues. They really frame it as a tool for ongoing skill management, integrating the data from the assessments, from the telematics to give those targeted interventions.
Right. And they did touch on the practical side, too, suggesting that operations with, regular computer or tablet access, typical shift patterns, they're pretty well set up to implement this, potentially even integrating the system's data with the telematics platforms they might already have.
Yeah, they even mentioned practical things like using an optional reward system,
Right.
like offering, say, airtime, just to nudge operators to consistently do those iGym sessions. It shows they're thinking about the real-world challenge of actually getting people engaged with it.
So it's quite a layered strategy then, combining the assessment, the feedback, the training, the data integration, even thinking about behavioral nudges, all aimed at this specific aspect of human performance. Okay, let's maybe start to bring this deep dive towards a close. We kicked off by highlighting that persistent issue, judgment error being a major factor in accidents, even with all the tech we have, and the limits of just reacting after the fact. Then we explored this proactive method proposed in your sources, which really centers on assessing, understanding, and actively managing operator psychomotor ability using specific data points.
And we saw how the sources suggest using data from those psychomotor assessments, and then, crucially, integrating it with the telematics data to build a much clearer picture of individual operator performance and their skill levels. The core idea really is using those targeted interventions like the AI-driven feedback post-assessment and that specialized iGym training specifically to help manage that natural decline in psychomotor skills, the one they identified as potentially starting after the early 30s.
Yeah, and just to reinforce some key takeaways from the sources for you, that striking statistic, the 45% of accidents linked to judgment error in that specific South African study. The concept that psychomotor ability can naturally decline after the early 30s, and the potential they see in their visual performance journey, that two-level process. Assessment, feedback, targeted training, all backed by telematics data to potentially improve key metrics. Things like harsh operating, fuel use, accident rates, and machine availability.
And just to reiterate that important point, the tool is very much presented as a way to proactively manage existing skill levels and decline within the current workforce. It's not positioned as an initial employment screening tool.
So, connecting this back to you, listening, this deep dive really shows a different way, maybe, to think about safety and training. It's one that puts the proactive assessment and, crucially, the support of the human operator's core physical and cognitive abilities right up front, informed by specific individual data.
Yeah, it's about shifting the focus, perhaps.
Uh-huh.
Moving from solely documenting what went wrong towards actively investing in and supporting the human skills needed to help prevent errors from happening in the first place.
And that leads us nicely into a final, maybe provocative thought for you to chew on, something stemming directly from what this source material implies. Given this idea that fundamental skills like psychomotor ability, they naturally change and potentially decline with age, how else could we apply this principle? The principle of proactively assessing, supporting, and managing these kinds of core human abilities using data, using targeted training. Where else could that apply? In other demanding jobs, maybe. Or even, in aspects of our everyday lives, way beyond just industrial operations like mining. Something to think about.